Okay. Before things get all exciting and everyone is coding, a few words on webhooks. And I know I have your full attention because you need this for the assignment. Thanks for switching on the monitors. That's helpful. Who wants to share what a webhook is? Well, what's a webhook? What's your understanding of webhook? Who has never heard about this thing? Good. Yeah. Who has heard about this thing? And who has played with this? Or anyone who has heard about it, what do you think it is? What, please?
I've used it for notifications between Twitch and Discord.
Yeah. Okay. So what does it actually do? I mean, just to get anyone who has never heard about it, what is the webhook about? Feelings?
I don't actually know that well. I just played with it, but like it allows you to hook into different web services and allow them to communicate even though they're not supposed to.
Okay. Well, that's a matter of definition, but you're right. The communication bit is the key. That's right. Yes, please.
So you can trigger something when something happens. Yes. It's a trigger. For example, if a build completes, you can have a webhook.
Yeah.
You get a notification, for example, on Discord.
Yeah.
So you can. It's basically a trigger.
Exactly. Right. So it's kind of an event trigger. If you think about what's the equivalent in programming that you may or may not use. Yes, exactly. Callback is the same principle, right? So you register something, and until certain, to register towards a given event, if that event occurs, you get this callback, right? This callback is executed, and your task is done. And that's how webhooks are de facto implemented as well. The only difference is there, of course, we're relying on REST technologies, right, for the sake of consistency. So that's basically the main idea of webhooks. I'll briefly go through some of the base ideas. So it's basically the idea of having user-defined HTTP callbacks, right? So instead of having some sort of functional specific programming language in which you implement it, it's kind of just purely based on the REST technologies that we learn about or have learned about in this course so far. And it is exactly, as you mentioned before, it's about triggering remote endpoint execution. So it's kind of, for example, for interaction possibly with between web services, but also for a mechanism for you to invoke your web service based on an activity that happens elsewhere, right? So it's no longer the user invoking the web service. That's something we experienced so far, right? From the assignment 1, basically you are playing some sort of interacting entity with your web service, like a machine behavior. But here the idea is that you tell a third party to invoke your service, for example. So that's the main idea. And fundamentally no difference. We're using the REST API. And we also, again, rely on the classical REST methods. It's just now, how do we architect such a system so that we can actually use it flexibly? And what do we need there? Well, we need to think about, we need to have a way by which we can register webhooks. So we need to tell the triggering party, so something that has an event, such as you mentioned before, if you have a build system and there's a new push to GitLab, for example, we need to tell that system, hey, how it can actually invoke our hook so we can do something on top of it, whatever it may be, right? So it allows you for the execution of user-specified code. So we need some sort of event specification. So the server needs to offer a set of events you can subscribe to. How else would it know how to react to you, right? And you, of course, need to provide a URL to hook. So the key thing is there that you, when sending a request to register register your webhook, you're sending a URL as part of the payload, right, of your registration. So this URL is invoked whenever an event occurs, right? That's the key idea there. And of course, as part of it, it's not just enough to know, okay, how do I register my webhook? And of course, you need to have the URL that's called back. Again, it has the same kind of burden that we saw in the REST specifications before. You need to have a fixed, generally there's a fixed payload associated with this, right? You need to commit to a structure, JSON or not, doesn't matter. Well, it does matter depending on the service, of course. But this is also part of the specification you would want to have and need, right? So use cases are kind of wild. Abstractly, it's really about effectively triggering your service anytime without initiating a pull request. We'll get to that in a second, the different patterns of interaction. Classical use cases, continuous integration. You mentioned that just before. If you deploy something and you want to have a third-party service work with you. Different API services allow you to hook into their feature set, right? So it's really third-party systems, and you can link your own activities to it. Project management is a classical one. Issue tracking is a nice one, right? So, for example, if your issue tracker would allow you to register your webhook, it could notify your web application whenever a new issue is lodged or closed or whatever the event may be it supports. And the other one is classical trading platforms, in case anyone used that. You mentioned the use of notification systems, and that's precisely what it is. If you, for example, bidding, right? Does Fin support bidding? Fin.no? Can you do bidding there? eBay, you guys know, right? So cool. So you basically do bidding, right? So you can get notifications usually based on emails, admittedly, but hypothetically, you could also or should be able to register a webhook that notify or is invoked whenever a certain price limit is or price target is hit, for example, and so on. And the other example is, of course, service monitoring. The operations guys know that, right? They get notifications whenever a certain CPU load is exceeded, or if systems are not responding, so on downtime, there's a certain threshold, and afterwards you receive notifications. So kind of the same principle, but now using web technology approaches. And so if you have your API already, what ingredients does it have, and how? Which ingredients are you missing for your, for the implementation of a fully fledged webhook system? As looking at your current assignment solution, right? What are the components you're missing in your system in order to allow the registration of webhooks? So you're allowing me to query your system, right? So, but what would you need to add in order to make that system able to receive registration for webhooks, so that it can invoke itself something, a third-party service? You need two facilities. One of them is to, of course, register the webhook, right? So you need to think about this. So you have a bit of an interaction protocol surrounding this, which is relatively straightforward, as you'll see. And the second bit, of course, you need some sort of persistence, because you need to store webhooks suddenly, right? You need to deal with third-party data in a wider sense. And instead of generally relying on the idea that we have GET requests and perhaps POST requests to our systems, for webhooks it's important that we think about the whole development cycle, right? So because you register webhooks, you may change or not webhooks, and most certainly you want to delete them, right? But of course list them as well. So we have the whole 4 CRUD operations that we generally implement when thinking about webhooks to get rid of it. But talking about webhooks and interaction patterns, the key difference is here that we are differentiating between 2 interaction patterns of services. One of them is the classical polling service, right? If you have your email client that doesn't have push notifications, on your phone, for example, it would, in specified frequency, poll information, about new emails or anything else really that's on your server. But what's the downside of this approach? Why can't we just use polling? Or is there a downside? So instead of registering your third-party service, why don't you have it just, request information frequently, so you can still figure out that your price target in the case of trading has been hit or the like, right?
It would be pretty bad if a million users try to do it at the same time.
Aha, exactly. Right. So, and yeah, so performance, right? The load on the server would be disproportionate, right? We have multiple users, single service, and they would just put load on a service possibly without any value, right? So it may just not have hit the price target in the case of bidding. And it's simply, it's wasteful as well, like in terms of operational load. Independent of the server, you put load on the network that's unnecessary.
It depends on what you want to do, because
Yep.
as you said, the bidding, there you might want to request, just in case someone bids and you want to know that they're bidding, but with Webhooks it might not be that important to have it update as frequently.
I see. Yeah, but I mean, the idea with webhooks is that you literally have a publish subscribe system. So what the model Carl is describing would be classically the. So here's your client, right? So that's your service. I didn't think about this as a. That's not legible, but it says client, I think. So this is your client you're actually interrogating from, right? Here's your service. And the obvious model of how to get those notifications, classical email clients do that. Basically, you're calling up a service and you get responses, right? You parameterize the calling frequency, right? So looking at package trading, what's the problem with this? If you say, hey, I'm triggering every 10 minutes because I'm very conservative and I'm respecting the runtime load of that service, what's the problem with this in the context of a trading system? Apart from the load. Timing, what precise?
If you send a request a second after you send the request, when it changes, you have to wait another 10 minutes.
Exactly, right? So you will not get updates on time. You may just be too late. I mean, it all depends then how you parameterize your timing, right? So your best bet would probably be to a penetration test, more or less, pretty much poll every second you can, right? Put incredible load on this. Of course, there's means of mitigating it, but in the end, it doesn't really help you because it doesn't. The response is specified by you, not by the event that is actually happening on the server. So the REST idea is slightly different. So instead of having the client poll the system frequently, it consists of a richer protocol. You guys cannot be able to see that, but you hear that, right? So I don't know. I'll just draw it up and then you can have a look later. So what the client basically does is it subscribes to a different service, so it sends a subscribe operation that does not have a follow-up per se. It's just a fully specified request. The server then keeps a reference to the client, and whenever the event actually happens in the future, the client is immediately notified, right? So up on the occurrence of the event. So if anyone bids 1 second after you, well, if you have just received the recent event, you would get yet another event because someone outbid you or whatever. It's probably the past tense, I guess. Outbid your price and whatever else. So the idea is that you're very close to time. You're very efficient in terms of notification because you only send information when it's actually needed, as opposed to you continuously polling. And that's also the idea of those of push notifications, basically, right? Instead of you polling all the time, you just say, hey, whenever you have something, here's my telephone number, call me, right? So literally, that's the original conception of a callback anyway. But even in this case, of course, the telephone number is your URL, right? Whenever you have something that corresponds to what I'm interested in, event, invoke that URL, right? So that's the key idea about webhooks here. It's not a complicated concept, it's just a different combination of REST technologies to facilitate this. But you, of course, need to do with certain things. First of all, you need to have a subscribe, and this is generally called the publish subscribe pattern. So if it's a bit like subscribing to a newsletter. When you subscribe to the service, right, every time there's some news to be published or some event to be had, it's published, right? So that's the key idea about this pattern. That's the relationship here. And as part, the difference to the polling one is, polling is relatively easy because you can just stop polling and you don't get any new information, no big deal. Here the thing is you remain subscribed, so you kind of need to unsubscribe as well if you don't want to receive further information, right? There's state that is held by the server suddenly, as opposed to just being blind response.
When the webhook is involved, does it use the same handlers as what the client, the user would use?
In terms of in terms of the client, not necessarily. The point is, it depends on what you want to basically do. For example, I mean, I'm working. Let's talk in terms of assignment 2, right? Perhaps there's so you implementing, for example, the counting of commits, right, and languages and all that kind of thing, and then you tell the system as the interesting thing that the service has is now it has those events. When, for example, it detects a new request, for example, on commits or language. So whenever a user requests this ranking that you have developed, right? The question is then, what do you want to do with this? And the idea in this assignment was basically to have give you the opportunity to register a third-party service, so yet someone else, in principle, your service. So your architecture would be something like this. This is now your service. It offers certain events, commit, and languages, and whatever else, right? Status, we had all this, right? So, and the idea is now that we have potentially multiple users. So one is the user, that's the person that's actually testing your service, or the service that actually uses your service on everyday operation. So then we have a third-party service whose role may just be to be notified whenever something happens on that service. Right? It just keeps track of it. So the actual invocation comes from a third-party user, but you as an admin, for example, want to know whenever someone uses your service. So for example, you can calculate steps on load. Right? You know, okay, what's the most frequently used endpoint? Right? How frequently is it invoked and stuff like this, right? Maybe interesting from an optimization perspective, right? So, and the idea is here, well, we have those interaction patterns, and of course the user gets some immediate feedback with respect to the endpoints of interest, but you as with this third-party service can basically say, hey, let me subscribe this service to any of those events, or one of those events, right? Event commits or event languages. That would be a subscribe operation. And notify me whenever such an event occurs, right? So whenever an event occurs, publish this information to me. So coming back to your question, the structure of what is responded generally does not correspond to the query response, right? So when the user says, hey, give me all the commits, what you produce a list of all commits and all that kind of jazz, all the nature as specified in the document, return it to the user. Here, this person just gets the notification as simple as, oh, someone has called a something on the commit endpoint, right? It doesn't need to be the same payload. You follow me? So it can be a third party, right? The user is someone else, then this service, for example, that just offers an overview or gets notified whenever there's changes on the server. Let me operate, I'll walk you through this using an example. Perhaps that's more accessible. Were there any more immediate questions to this pattern? So this guy may well do polling here, right? This user may constantly interrogate, right? But upon every interrogation of the service, invocation of the service, this third-party service gets notified. Hey, someone is interrogating your service, right? It could be a preventive measure that sits behind it, or just an overview, correcting stacks, you name it. But that's the idea. Especially if you run a service, you may want to have the facility to, collect this information, or provide user with the facility to be notified themselves, just to reduce load, for example, right? So if you write a trading platform, monitoring system, and so on, it may be in your favor of doing so. Cool. So that's basically the idea. For you, important is to recognize the different interaction patterns, polling versus publish subscribe. That's something you'll see again and again. You have learned it in callbacks already, in the context of programming, but you'll find it more commonly, especially in the context of web technologies, that you need to use this idea. Okay. So we have two perspectives there. If we look at the schema there, we have this service that actually offers the registration of webhooks. And then there's the invoked service, right? So we need to think about both now. It's a bit of a multi-party interaction system. So we need to think about the registration service first. So what endpoints does it offer for the registration of a webhook, right? Including the methods, for example, the payload structure, the events it offers upon which things can be invoked, and of course the invocation of whatever has been provided as the payload, right? So if the URL, the invoked URL has been provided, the service itself suddenly needs to be able to invoke, that particular URL whenever the specified event happens. And the other service, the invocation service, this just needs to follow the structure, the payload that is specified. So whenever you register a webhook, please expect the following payload whenever we call you. That's the kind of thing that the invoked service needs to deal with, and of course the methods associated with it. So let's have a look at the example to illustrate this a bit. So This example is also in the repository, so it's called Webhooks demo, so you can just explore it on your own if you want. But I just want to give the intuition sitting behind it. So fundamentally, the idea here is, abstractly speaking, we have a service that offers two endpoints. One of them is called webhook, very descriptive, and the other one is called service. And the purpose of this webhook endpoint is to deal with this whole registration bit that I talked about, the subscribing, unsubscribing, and so on, right? So in principle. And the service endpoint is a regular endpoint that exposes service information, such as your commits endpoint, language endpoint, whatever else in your current assignment too. So looking at the handlers, we have this webhook handler, again dealing with registration, and we have the second one, the service handler, dealing with regular use of that service. So the service is dummy service, doesn't have a particular value other than showing a subset of the webhook functionality. So the webhook handler here deals with the registration bit. So what's the idea? Well, what do we need for registration of a webhook? What information would you expect if you were to register a webhook? I show you there's a handler and you need to send something to it. What do you need to know in order to send something to it? Please. Event, yeah. What else?
Some address of some sort.
Yeah, the address. Okay, yep, that's cool. The endpoint, the actual complete host address. Yep. What else? What else do you need? How does it know what to invoke whenever an event happens?
URL.
Correct, right? So you need to find some way of providing URL and the event and so on. Generally, you would expect some sort of payload specification for the body of your post request, most likely. So that's the idea here. So that would need to be something that's exposed, of course, to the user. So it needs to be some sort of documentation feature, right? So in this case, quite straightforward. Webhook registration consists of, let's say, URL and event, right? For the sake of simplicity, quite straightforward. No magic there, really. So whenever a user wants to invoke or register something on the web handler, it would call the webhook endpoint and provide this struct, and it's not this struct, and this would basically then be passed through this particular handler. Again, the usual stuff with switching on method. Right now, it only implements post and get, right? So post a new webhook registration, get all registered webhooks, and otherwise throw arrows. So this one is, of course, incomplete. It does not represent deletion, for example, or changing of webhooks, just for the sake of simplicity, because that's two other methods for doing it. So how does it work in practice? Well, you decode the webhook into this webhook struct, and then we register it somewhere, the state. And for the sake of simplicity, again, we have a simple database, which is just an array of webhook registration. So it just keeps track of whatever has been sent in, right? That's the key idea. So generally, you would expect, when you register a webhook, you would expect the system to tell you, okay, under which address or how can I access this webhook for future reference? Because it suddenly becomes a resource in the system, right? You want to be able to change the resource, meaning the webhook. You want to delete the resource, meaning the webhook, and so on. So generally, the expectation of such systems doing registration is to return the unique identifier of that webhook. This is not guaranteed by this approach because I'm just using an array, so we don't have any an association here necessary. I'll show you how it works in a second. And the other method we have is the method get, and that just shows you all registered webhooks. So you can just see in the system what is registered there. And in all other cases, it would throw a default error because it doesn't support any other method at of this stage. So now I mentioned, okay, now we need to deal with the events. The events are not explicitly ended. The idea here is that in this example, it just will notify you upon anything that happens, right? So you would, of course, need to differentiate between the events that are registered and check, okay, did someone else just perform, for example, a post request, for example, or a get request or whatever else. So here's the service handler idea. So this is used by the user in kind of everyday use, right? So this is where it would correspond to, for example, your commits or languages endpoint. And again, here, the only thing that's implemented here is a post request. So whenever you receive a post request, notify the webhooks. How is that done? Well, you iterate through the webhook structure and simply call their URL and inform them about the associated event. That's the key idea there, right? Recall that the webhooks have a URL and an associated event that actually occurs, right? So, upon which they want to be notified. And that's what you basically do. So in addition to doing what your service is actually doing, it also sends this notification to all registered webhooks. That's the key idea. So in order to test this or to explore this idea, we need, of course, not one service but two web services, right? So we have another kind of mini web service here that plays the registering or invoked service, so a third-party service that just listens to whenever something happens on the actual server. So the idea here is, let's put it on a different port, of course, surprise, surprise, different service. And we just have one handler here for the sake of simplicity, the invoked handler. And the only thing that thing actually does is just reading body and the method, right, and printing this to the command line. So it basically takes anything as a dummy service and prints it to the command line and sends a response to the sender to indicate, oh, I actually successfully received your invocation. It has been executed, right? So it's just takes anything kind of thing that for the purpose of this exercise here right now. Of course, if you specify a particular payload structure for the invoked service, well, you need to consume that, right? So if there's a richer set of information that, for example, identifies the caller of a given service, or more richer payload information. Here's just a string we print out. So we have two services. We have the invoked services and we have the registration service. There's a comment, please. Who was first? I don't know. Please.
Is
Yep.
passive name
Yeah.
the same package?
I put them in the same package, yes.
Do they run at the same time?
They will run the same time in a second, yes. Because I just start them separately, so for the sake of convenience, I keep them together. In fact, for this reason, I keep the passive server completely self-contained, so everything is there. It's kind of just a dummy service that reacts to nearly anything. You can send it, basically. That's the idea. It's good for debugging.
Second question?
Second question, sorry, yes.
Yeah, I was just confused by port numbers. But
Because two services, right? One runs on port 8080, the other one on 8081, because I need to have two servers, otherwise I can't show this. But
in practice, you would put them on different.
yes, and we do that as well. I just want to show that you register multiple, not only one service. So, right. So we have now the service that allows the registration of webhooks. Okay, that's good. So now we need to, of course, have the second service that we want to register to receive notifications, right? So I run this separately. You have two tabs here right now. Then, eventually, there you go. And it tells me, cool, this is my URL, right? This is the URL I want to register. Now, if we come back, if you want to register anything to the actual registration service, what was the URL? Well, let's come up with this. We need to send a post request to webhook with the associated payload, and the payload was described here. Just a second, I'm bringing up Postman so we can motivate this interaction. Good morning. So he's joining me. So. There we are. Cool. Not sure if that's legible. I'll just bring out the. Rather use this magnifier. Let's see how that goes. So the idea is as follows, right? So we have our registration service running on port 8080 with the endpoint webhook. And this was the structure, right? We provide a URL and an event or whatever else. I mean, the payload could be richer, it could be more limited, and so on. So what do we tell it? Well, please, whenever you have an event, invoke that URL. That's the key idea, right? We send this as a request to the server. Hopefully you get it to 100. We do, good. And it returns, in this particular case, the unique identifier of that service as registered on the server side. So if we now run, let's see. as I mentioned before, if we just run now a GET request here on the same endpoint, we should get a list of all registered webhooks. And just for the sake of validation, there you go. Well, it's only one registered webhook there, right? We literally get the structure of the registration back, right? The invoke webhook and the post event. Okay, so far so reasonable. So one of the promises was now, okay, we have our service waiting there, and it's so far nothing has happened. But if we want to find notification recall, we need to call the other service endpoint, right? In this case, again, service. Simply called service, could be commits, languages, whatever else, in its usual fashion. So post request to that one. And the idea is there, then whenever we do this, I'll just close the magnifier right now. Whenever we do this, we expect now invocation of this service. Recall, this is the second web service, the one that is to be invoked. And the first one basically just takes the registration and listens to events upon which it does the invocation. So if we send a post request to service, well, we get a 200. That's pretty good. And we'll see that the second web service actually has been invoked, right? So it actually has received something, and it's just printing back the information that it actually has received. So if I now go into the service handler, for example, so what was the information that I wanted to send to this registered webhook? Well, it was basically sending as payload, invoking the URL and sending a particular payload, in this case just a response on registered event in webhook demo, and associate the event with this. Quite straightforward. And this is precisely what the what should have been invoked on the webhook in this particular, right? So it says received invocation with post method and body response to registered event in webhook demo. That's the basic idea here that we can do. So you just said, well, why use local webhooks? No point, right? So let's use a third-party one, because there's a nice site. It's worthwhile for you to know, especially if you want to do development or debugging as well. The only thing it doesn't do is provide you meaningful feedback, but this is not a primary concern. Let's do this. And it's called webhook.site. What does it do? I nearly got there. Right. Well, it's about testing webhooks. Quite a neat idea. So the idea is there. They register and give you a webhook, cryptic one. So that's how you usually see webhooks anyway. They have a cryptic URL, so as to avoid guessing them, right? The invoked URL one providers, of course, a very primitive one, a very simplified one. So what people do is actually use hash algorithm to have a reasonably complex output there that is not guessable. But this is the webhook they have now registered and that we can use uniquely, right? So if you call the website, you get another unique webhook. Let's use this one to register our to our own service, and we can do this whenever my system responds. So instead of using our local web service, which is fairly straightforward and just prints everything we get, in fact the online one does the same thing. You just send this to our webhook endpoint, and it says, yep, okay, 1. It says, well, I registered you as well, and the unique resource identifier is 1. It doesn't provide the full URL, it could, but for the sake of it, it just provides you the index. So if we look at now at all, all right, JSON, so it's more beautiful. If we now look at all registered webhooks, so I send a GET request to the webhook endpoint, we see, okay, not only do we have registered our local webhook right now, the kind of simple service, the dummy service, but also this, remote one. Okay. So, and now we can basically do the same thing. Whenever we use this, the other endpoints, we expect some sort of notification. Let's try this. We're sending a request, and this request somehow is processed. And we look at our second invoked service, and again, it received the same, of course, but still an invocation. And it basically just says, on the server side, here's for the sake of just providing some output, it says which services have been invoked, of course the earlier one that we had, and the newly registered one. If we now check the website for this, the webhook.site, we'll see now, oh, we actually have received some post requests here from evidently our URL somehow. And we even see the content here, right? So we got a post request from our service, and it provided with the same response, right? Response on registered event in webhook demo with the method post. So that's the key idea. So you can now register an arbitrary number of different webhooks and so on. Whenever this service endpoint is invoked or called, they will all be notified that something has happened. That's the key idea, right? So you register for an event, and every time that happens, you get a notification. So if I run this a few times now, just for the sake of it, let's see. Well, still 200, that's pretty good. We'll see we have an arbitrary number of notification, right? So anytime something would happen to the service, we would get this notification with corresponding details and so on, right? And the same, of course, holds for our passive service here as well. It gets the same number of registration or invocations as well there. So that's the basic idea, right? So so webhooks allow you basically to register with events that happen on the server to do something else with it on, you know, your third-party service. So coming back to assignment 2, it's precisely what you mean to implement there. Let's see, we can bring this up. We look at the lower part of the section. So those are the usual endpoints we're used to, but there's this webhooks endpoint down there. And this is specified at the far end here. And what should it allow you to do? Well, it should allow you to register a new webhook, you know, with a given URL to given events, right? So the events correspond to your endpoint. So for example, if the commits endpoint is triggered, please invoke this URL. That's the kind of payload that you would specify here if you were to provide just commits in the event. So the idea is that you only register to one of those endpoints. That's the idea here, depending on which ones you implement. Yesterday, you recall, we decided that you only need to implement 2 out of 3, so it depends on you which ones you actually want to use out of the 3 ones, commits, languages, and issues. So when you send your webhook for registration, the only thing you want to expect is basically a unique identifier that tells you, you know, what's the ID of that webhook in your registration system. Generally, it's, you know, integer representation 1, 2, 3, 5, 4, and so on. And then you should be able to also send a GET request to this webhooks endpoint, for example. Why do I have to re-put check there? Yeah. And it should return all registered webhooks, including their ID, events, the event is subscribed to, and the timestamp of registration. So on the server, you would want to keep track of that as well. And in addition to that, you should be able to individually observe webhooks. So instead of just sending a GET request to the webhooks endpoint, right? So in this case, webhooks endpoint. If you send a GET request to a resource identifier, so webhooks1, send me information of webhook1, you would only expect this information to be returned. Please.
I assume there's supposed to be a v1 in there as well? On the repo check.
That is correct. There's a, yeah, that's right. Very good point. Yeah. Good spotting. Thank you, we need this. Because that's the kind of thing that escapes you. Of course, the URL is always consistent, right? So it needs to be v1 webhooks because that's the API. Cool, yeah, that's right. So we can request, the key difference here between those 2 different GET requests is one is done to the root, repo check v1 webhooks, in response with all webhooks that are registered. The other one is repo check identifies a specific webhook, repo check v1 webhooks and /1, for example, and then you get at payload just get the individual webhook information again. And the third thing that of course needs to be specified, how the third-party service needs to react, or what payload it needs to be able to process. And that's specified here, right? So whenever being triggered, so the third-party service, it should expect this kind of struct that includes the event type that has happened on the server evidently, the parameters that were passed along with the triggering request, so further information, and the timestamp upon the invocation. That's the kind of information you want to see on your third-party service. Again, for the purpose of testing it especially, you can, of course, just register something like this, right? You just take a uniquely generated URL from webhook.site, and it will just show you whatever you actually receive. So for the purpose of debugging, you don't need to reconstruct this third-party service. You just use this debugging website, right? So it's not part of a submissible. The only reason why I put it in, I just want to show you how fundamentally basic those invoked services can be, right? So if you just dump anything, but I think using those websites is quite helpful, also because they show you a lot of meta information that may be helpful with respect to identifying issues in your implementation. Before you spend more time on this, I think that's the key idea I want to get across. Does it somewhat make sense? Who is lost? Why are you lost? Where specific? Give me some help, like, so I can help you.
What is the user?
Right. So in this particular case, so we have two things. So coming back to this graphic here, the user. So this is the user. Some of you have implemented the commits endpoint, right? Good. Cool. So this user is only interested in commits endpoint, nothing else. So that's the reviewer of the assignment. That's me. It's Marius. That's whoever, right? So Jonas, reviewer. So the user is unaffected de facto, right? What the user sees is the user sends the payload request. I want to see all the commits and all that kind of magic, right? You do your processing on the server side, and you provide the feedback as specified. That's something you did already. The only thing you need to do is, for this third-party service, is, well, if it's interested when a commit endpoint has been invoked, so meaning when this user poked your commit endpoint, right, then send me a notification. The user does not know about this, or doesn't need to know about this third-party service. Right? So this, for example, here, and I'll give you an example. If you are interested, right, to get information when we invoke your service, right? For example, to spot, okay, what are you actually doing? How are we poking your service? Are we providing invalid parameters or whatever else? Or just get an understanding of the level of load that is on your service, then you could register your own webhook. We would not know about this. It's totally independent operation there, right? But whenever this query happens in this assignment exercise, you would notify any possibly registered third-party webhook, right? The one from webhooks.site, one you wrote yourself, a dummy webhook, you name it. It could be an arbitrary number of them. That's the key idea about webhook. So it does not affect the user. So this endpoint that you did, done. The only thing is that your system needs to recognize, oh, there was an invocation. If I have webhooks registered, notify them. That's the only thing I have. Yeah, it's like a notification system, like when you get new emails on your smartphone, it shows those little notifications there. It's the same kind of principle. The sender will not know that you got this notification, right? So if someone, for example, a university reminded you of a deadline or whatever else, they will not know that you got a notification about it and just send it to your mailbox, whatever happens from there. But your mailbox application sends you a notification, right? And that's like a webhook. The only thing that webhooks use URLs for the invocation as opposed to other unique identifiers.
One thing I was wondering about is when or you who register a webhook and use it to check, for example, commits, do you need to have a server up and running or something to receive it all the time, or you can check it later?
No. So you are fundamentally right. You, of course, this URL you're registering needs to be accessible, right? So if there's a 404 on the, so this service is trying to notify you, gets a 404, yeah, I don't know, that it most likely will just forego the operation, right? And then, you know, of course it will not die, right? It shouldn't, right? So it needs to be gracefully with those cases. But yes, your service needs to run. That way, you pointed out, it's between service interaction, right? The assumption is that the services are running, service 1 notifies service 2, possibly notifies service 3 and whatever else, right? It's just an expansion of getting away from this mere one-to-one interaction, but actually to expand the richness of potential interaction of services, right? So they can, when, for example, you could chain this whole idea a bit in the sense that when you send a request, this service can invocate a third-party service, and this one could in turn again, upon this event, register, notify someone else. So you can decouple your entire system into a set of services that are interlinked via webhooks. That's the key idea here. We just exemplify this using this, of course, a very simplistic example.
Could you use that to sort of automatically unsubscribe people who don't anymore have a...
Very sensible. I mean, if you get a 404, I probably would at least put that service invocation on hold, perhaps test it 2 more times, and then probably throw it out if I constantly get a 404. Exactly. But this is the semantics for this are really on you, right? So it's up to you how you deal with this, because the only thing that we see publicly is, first of all, the payload, the possible REST methods we are allowed to use, but the semantics sitting behind you, what you do with this, as before, is totally on you, right? So it's just the interface. The implementation is your choice, but that's a sensible move. You don't want to have, have constant timeouts on services that haven't registered or haven't responded in half a year or something like this. There's no point. That's right. I mean, I think you should deal gracefully with errors, but I don't think you need to have an advanced management system that deals with those kind of ideas of purging your repo registry regularly and so on. The only thing we want you to do is basically allow to register webhook, see the webhooks that are registered, and play with them for actually allowing the invocation, right? That's the key idea there. Is that come back to you? Is that a bit clearer now? You mentioned you were raising your arm as well. What's same thing? So it's really about basically building a notification system in the widest sense. Yeah. So the classical example is CI. No, we'll probably not get there, of course, but the operations guy knows that perfectly, right? So whenever you push a new commit, for example, in GitLab, in principle, GitLab allows you to notify a third party, oh, something has happened on your repo. I need to do something with this. For example, trigger a build process, or send an email automatically, or post to a Discord channel if you want. So just to know, new commit, right? Could be as simple as a simple notification. There's no semantics attached as to what happens after that. It's just some way of notifying another party about a particular event. That's all it is, right? Because the payload is kind of up to you. Not in this assignment, of course, because we pre-specify the payload. But if you implement webhooks, rather, you specify the payload that a webhook probably could be able to receive, right? And that constrains, of course, the nature of the information it can receive as well. It can be wide or small, whatever else. It can also be just a string. I mean, it doesn't need to be JSON, in fact. But in this case, of course, we want it.
For the persistent storage
yep.
with this, say we use Firebase, and then we got the good message that we're not supposed to push our credentials, which is nice.
Yep.
But then if you build it, so you build your because we're supposed to Dockerize it, right?
That's the idea, yeah.
So when you build it, you get the binary file.
Yeah.
So when you build it and you have access to the credentials file, then the credentials will just be stored in the binary file, right?
No, I can read it.
Mm-hmm.
I mean, if you
No, you build it locally.
Yeah, you build it, but you don't compile input files into the binary. So say
So you would have to also copy the credentials file into the Docker container.
Oh yeah.
Oh yeah.
You need to have the credentials because that's like the key, right? And
Yeah, definitely. But you need to have that as well in the Docker container.
Yes.
In OpenStack.
Yeah.
But it's a service account. It's not your personal account, right? So that's what you were talking about. You get your service. Sure, always with. But at some stage, you need to do it. I mean, because even in Docker, if you build something, eventually you need to expose the secrets to in order to allow the autonomous operation of the service, right? So that's a risk. But in our case, I mean, I think it's somewhat moderate. First of all, you manage the virtual machine yourself. It's in-house anyway, so it will never leave your control, unlike a Roku that you mentioned before, which is true. But in this case, it's really under your control. So this risk is manageable. Again, it's a service account. It's not like, it's your personal account. You can't access your emails anymore. If you block you, well, bad luck, then the service doesn't work anymore, and you create a new one, right? So that's a relatively cheap one. But good point, yes. But yes, you will need to provide it. Webhooks. So what I would recommend you is try that demo. copy that thing from the repository and run it. So basically run this invoke service and play with the idea of registering it all. Just register as I did a third-party service and see how the interaction actually works, right? So perhaps it makes more sense as to why it works. But I think the idea of having a publish-subscribe pattern should be something you should think about more like a design pattern for your entire system, because you will see it again and again, especially contra web technologies. But it's kind of pervasive in the meantime, because it motivates the idea of very loose coupling, right? So you can really decouple those services. The only thing they're bound to is basically a subscription protocol and the payload structure, and of course getting the right status codes and things like this. But the coupling is inherently loose, right? And that's the idea with webhooks in particular.
There is
more expansion.
Yeah, there like for the assignment you don't need to think about it, but if you were to design kind of a webhook system for yourself, you have to of course make sure that the listing of all webhooks is not available to everybody. It's like admin only can list all the webhooks. It should prevent different users registering different webhooks to mess up with each other. So like ability to delete a webhook should only be for your own ones, not for everybody else's. So for example, using indexes 0, 1, 2, 3 is a bad idea, because anybody can say, oh yeah, undelete webhook 0, right? So you have to somehow prevent those abuses of the webhook API. Most systems, they just use security by obscurity, so they
that's just like that.
So they manage by some kind of unguessable hashes. So that is one possibility. The other one is you actually authenticate. So you have some sort of token, and all the interactions regarding a particular webhooks are managed by the token. So if somebody doesn't know the token, they cannot unregister a particular webhook, and so on. But those are kind of a more advanced things that you may not need to deal with.
No, not in the assignment. No. But in future, most likely, right? So if you deal, again, as Mark said, if you see third-party webhooks, for example, one nice extension for your assignment, I would think about could be to integrate it with Slack or Discord, right? So you basically get a notification on Discord whenever. So instead of building this, simple third-party service, actually have a notification in a chat system of your choice, which all of them really provide the notion of webhooks. And what you get is something like this. For Slack, for example, they always look like this. Very cryptic webhooks. They don't require authentication, but again, because they're so obscure, they're practically unguessable unless you control the infrastructure in between. But that basically means they don't need any authentication per se, but this is what you would get. And you just bluntly send in a given Slack-provided structure the payload of your message, and it would display in your channel or whatever else, right? And then again, the authentication for advanced registration. But for sake of simplicity, here's really about principles. You just create a webhook, you get some sort of unique identifier, you need to be able to modify the resource and delete it. Dealing with this hashing is something you can make an advanced if you want to push it, sure. But that's not required for the assignment in any case. So it's the idea there. Good point. Is there anything else I want to talk about? No, that's good. So Slack is a good example. I mean, if you want to push it further, I put the slide outs anyway. Then you can see how it's done with Slack, for example. If you want to just play with this and use that as part of the integration.
Yeah, we played with Discord last year, and it worked well as well.
It works. So Slack also very nicely did 2 years ago, so that worked also quite well. Yes. That's basically it from this side. If there are any further questions regarding this specifically, or else we can just help you in your whatever doings you are busy with right now in terms of assignment. Cool. Let's cool. Let's turn to the assignment then. Yep.